I'm Jennifer Williamson with Pacific Northwest National Laboratory. I'd like to welcome you to today's Energy Code Commentator webinar on REScheck Basics. We hold this webinar series the second Thursday of every month at the same time, so keep watch on BCP's training page as topics get added. We are still looking for some topics, so if you have something that you'd like to see, go ahead and use the email in your webinar reminder messages and let us know. Our speaker today is Pam Cole from PNNL. She's our resident expert on REScheck, and we appreciate her sharing her knowledge with us today. Pam, it's all yours.
Thank you, Jennifer. Hello, everyone. Thank you for attending the webinar today on REScheck Basics. So our topic for today, the course description, is really understanding the basic functionality of REScheck. Look at how you generate compliance reports and some of the new features if you're a REScheck user and you're just logging on to see what's the latest and greatest. We'll go over some of that as well. So our learning objectives. Again, we're going to have an overview of just the basic functionality of how the software works, how REScheck calculates compliance, how you can go in and identify construction specifications on your plans, what's needed to have in front of you actually before you begin your REScheck, learn what building envelope components that you'll need to be familiar with to enter into the software, and then understand how the compliance reports are created and what they entail. So, Energy Code Compliance Tools. And when I go through the presentation today, I'm going to go through some slides, a series of slides, and then we're going to look at the REScheck software. But I have to kind of tie it to an actual energy code, so to speak, because it is an energy code compliance software tool. So with the energy code, there are different paths that you can take, and there's different tools that you can use depending on the path that you take in the energy code that you're working in. So there is a prescriptive path, and actually if you're choosing the prescriptive path in the code, there really isn't a tool really needed. You can look at the prescriptive tables in the energy conservation code, and you could fill it out by paper, but that's one option. There's a total building UA trade-off that's in the actual IECC, International Energy Conservation Code, and that is what software REScheck is built on. And we have not only a web-based tool, but we have a desktop version right now as well. And then there's an energy analysis option, which is full energy simulation. And in the most recent versions of the IECC, there's actually another new path, Energy Rating Index, ERI, that you might have heard out there. And that's in the most recent 2015 IECC. Well, and there's different software out there that does full performance, such as REM Design, REM Rate, Energy Gauge, and so forth. REScheck is not a full performance-based tool. It is, again, it's in the middle here. It's a total UA trade-off, and it follows the path that's in the code based on that. So here's just a screenshot of the energycodes.gov website. That's where you would go out and grab the software. That's if you wanted to download the desktop version or you wanted to go out and get on the web tool. So at energycodes.gov. This home screen page has already changed. This was to the National Codes Workshop, and I just presented there back in March. So it's a screenshot of that conference, but now there is something else that pops up. So we keep it pretty current on something that's going on within the program. So you'll see something different on the screen if you go out there today and look at energycodes.gov homepage. And here is the REScheck page. So if you were to take down this URL, energycodes.gov/REScheck, here's where the options are, and you have two options. You can either download the software, and it's Windows-based. You'll see in the middle of the screen, and I know this wording is a little small, but underneath where it's in the middle where it says Windows and then it has Mac, we don't support the Mac version any longer. It's discontinued because we've moved to the web-based tool. So if you are a Mac user, then you're going to want to go out and use the REScheck web tool, and I highly advise that you register with your email and a password, because you're going to want to save your projects. So you'll want to save your data, and then you'll want to save your reports, and they're created differently. There's a data file, and then the report is created as a PDF. Then also there's technical support. So with the program, the Energy Codes program, we do have a help desk. And you can submit questions in that help desk. You can submit questions on the National Energy Codes. You can submit questions on the software tools, REScheck and or ComCheck. We have a ComCheck tool, and that's on commercial buildings. And we are going to have a series of webinars on the ComCheck software as well later on in the year. And it is, again, this help desk is strictly a site, a resource on just energy codes, though, and the supporting software tools that the codes program supports. So if you have like a plumbing question or electrical question, a fire code question, you would need to go out to another resource, maybe the International Code Council. They have a forum on other various codes because they actually publish the codes, that you could go out there and get your question answered on other codes that you might be dealing with. But this is strictly just the energy code. So here's two screenshots of the desktop tool and then a screenshot of the REScheck web tool. Today I'm going to show you the desktop tool, and there'll be some screenshots of it, but the functionality and the way the software works is the same. It uses the same engine. It's just that the real estate, that I would call it, the way it looks and way it has some features are a little different, desktop versus the web. So there are some things, but again, the back end calculates the same. It's running the same codes, does the same thing. Now, why do I have both these screens up? Well, because if you were to create a data file and you had the desktop version, you can actually open it up in the web tool. So you can use both tools with the same data file, so they can work in between each other if you had to do that. So like if you were in a remote location and you might be using the web tool or vice versa, you can work in between these two. A lot of people like the web tool because if they have several people involved in a project, such as if you have a lighting designer, you can't enter lighting into REScheck, but in commercial buildings it might be important. Or you might have two contractors involved that want to look at the actual project. You might have a generic login, and they could log into the project. So the web tool is kind of nice because you have more flexibility that you can go log into it no matter where you are if you have access to the internet. And the data exchange is what I just talked about. So if you did log on and you saved your projects out to our server, then you could always go out and pull those. If you save them to your desktop, then you're limited that you always have to go to your desktop computer to open up those data files. So that is a nice feature that the web tool gives you, that more flexibility. So a walk through the REScheck steps. So the first thing, and this is just some teasers to give you some helpful hints as we go along and learn how to use REScheck. And again, this is just the basics of REScheck. This isn't the advanced class. I'm not going to get into some of the technical calculations in the back end. We are looking at maybe having one of those type of webinars, but this one really is just the real generic basics of REScheck. So the first thing that you'd want to do or that you'll want to know is what code. REScheck has options for several codes, and Department of Energy supports the most recent published IECC and then 2 versions back. So you could be in the 2012 IECC. Your state or your location might have just adopted the 2015 IECC. So it's really important that you know what code is applicable in your location. If you don't know, you can go out to our state pages, and actually the REScheck software has a link that'll take you out, and I think I have a screenshot of it here in a little bit that shows you the status of state codes. The next thing is that you'll want to enter your project information, so the location of your project, the city or the county, who the builder is, if that's applicable, and any of that information in the project area. Then you're going to want to have in front of you before you start a REScheck, you're going to want to have all the specs, construction specs. So you'll want to know the building envelope components. And then mechanical equipment, it's optional anymore. There are no trade-offs for mechanical systems in the most recent energy codes, and you don't need to enter mechanical equipment. It needs to meet minimum efficiencies regardless anyway. And the software does not do load calculations. So within the codes, doing load calculations on HVAC sizing or duct design and duct sizing, REScheck does not do that. You would need to use another mechanism to do those calculations. And then there's a requirements tab feature that I'll show you that actually all the stuff that you enter into REScheck is not the entire code. But what's nice about the software is that it provides you a list of all the other code requirements that are in the actual energy code, and then you will go in there and confirm that you're going to meet the rest of the provisions. There are mandatory requirements that are in the IECC, such as, in the most recent one, air leakage testing is one of them. So those requirements sit in the requirements tab, and they're not actual entries that you would enter into REScheck. So as I mentioned, here is a screenshot of the actual status of state codes. So you could go out there, look at the map, or you could actually click on your state from the drop-down list and go out, for example, if I wanted to know what's happening in Washington State, where I'm from, they have their own state code, and it just happens to be that we have their state code as a drop-down in REScheck. But we don't have a lot of state codes in the software. That's just one unique one that we do have. But you could go out there and look and see what's applicable within your location. Another feature that's within the tool, it's called Preferences. And it's a menu that's up at the top of the program. And this lets you kind of customize things. So I can go under General and I can look at File Options where I can tell it where I want to save all my projects. I can also tell the software, if I'm in the desktop, that I want it to go out every 3 months or every 2 weeks and see if there's a new version available. We do have build versions that we call them, that we put out on our website. Say we have a significant upgrade to the tool or a new code comes out. Well, when the new codes come out, we're actually working on those and trying to get them implemented into the tool. And so you might want to have that feature where you want to go out and have it look for the version updates. There's also an upload usage data. You can turn that off. We can actually capture data. One thing that is in a great need is data, and for us to analyze data. And when I talk about that, when you're out there looking at the REScheck web tool, and when I said you can save your projects, we don't share proprietary information. We wouldn't, and we're not allowed to. But we might take a look at, for example, I want to know the average amount of insulation for ceilings in Texas. And if we have that type of data, we can take a look at it and see how many people or how much data is available for what's the average amount of insulation in climate zone 2, for example. And we might be able to take a look at that based upon the data that's been uploaded to our servers. But again, no proprietary information is shared with anyone. There's also a project feature, so I can default to a specific code and location every time. And the applicant, there's project details. Like if I'm a builder and I'm doing lots of REScheck runs, and I don't want to enter my builder information every time, there is a feature in REScheck under Preferences that allows you to just enter it once, and then it's saved there, and so it'll automatically open up your builder name every time that you open up REScheck. And then there's a report feature. Maybe I want to have a customized signature line. You can customize your reports for your signature as well. Or maybe you have 2 signers. You have an architect, you have a contractor on site, and both of you are signing the REScheck report. You can customize that signature line under Preferences. And then you can actually email these compliance reports right from within the tool. And that feature works in the desktop version and it works in the web version. So both of those have that feature, and you might want to put your email in there only once. So if you're going to become a heavy user or you are of REScheck, under Preferences at the top, the menu, you can put your email in there and then it'll automatically populate that feature where you don't have to type your email in every time. So project information. There's your city or county. And in REScheck Web, you have the option right on the project screen. You can choose from city or county. In the desktop, not so easy to do. It defaults to city locations. And if you want to use counties, then there is some explanation that's in the help section, which is in the Help menu in the explains how to do that. And also, what if your city's not listed in the drop-down list? Not every city is in there. If you live in a small town, such as where I live, has one gas station, my city's not listed in the software, then I would find a city that's the closest to my location that has similar weather, and I would use that location instead. However, you would want to check with the building official that that is okay with them. The code official, building plan reviewer, they have the final say of what they will and will not accept. So you need to make sure that they're okay with you using a city that might be next door, so to speak, that is okay with them to submit a report doing so. The big thing to keep in mind is that the code is tied to climate zones. The city locations are tied to climate zones within the code. It will give down in detail city data, so heating degree day, cooling degree day data, if you choose city. But I won't go into any more details about that, but it is tied to the actual climate zones that are within the code and the prescriptive table. And we'll get more into that in a minute. With project type, you also have the options to choose from single family, so one family unit, multifamily, which would be 1 or 2 family dwelling, or it could be a more than 3 dwellings, as long as it's residential. And the residential definition, meaning 3 stories or less above grade. If it is greater than 3 stories, it becomes a definition that would fall under the commercial code. And if it's multifamily, greater than 3 stories above grade, then you wouldn't be looking at the residential code, and you would want to probably go look at ComCheck software, which is for commercial buildings, high-rise, multifamily. Then it also has an option to show compliance for additions and for alterations. And the alterations feature is a little bit different in the software than showing compliance for new construction. So keep that in mind. Project details are optional, and all of this information can get printed on the report. So I talked a little bit about multifamily, the 3 stories, and here's a screenshot, again, repeating about what is the definition of when it falls residential versus commercial. So the 3-story is the cutoff, unless you have a state-specific code that has a different amendment, and there are a couple states out there that have a 4-story limit, but the actual National Energy Code is 3 stories or less height above grade, and contains more than 3 attached dwelling units. So some examples of that would be apartments, condominiums, townhouses, and so forth. So some helpful hints. If you're selecting addition or alteration from the project screen, so for additions, what is an addition? That's an existing home that you're adding conditioned floor area to. So let's say that you are going to take and you're going to remodel the garage, and you're going to make the garage a family room. And the garage used to be for cars, and it was not a heated and cooled space. When you are taking a garage and you're converting it to livable conditioned space that's going to be heated and cooled, that would be considered an addition. There's also a feature for alterations. So what is an alteration? Alteration is an existing house that's heated and cooled, heated and or cooled, and maybe I'm replacing some windows. That would require a permit, and that would be considered an alteration to an existing building. So when if you're adding new conditioned space, that's an addition. If you're starting from scratch, that's new construction. If you are altering a conditioned building that's existing, that's an alteration. And you would choose from those 3 options within the tool. So what is important to know, and what type of information do you need to start your REScheck? It is the building thermal envelope. And here's a screenshot of the building thermal envelope. So we're talking about really where the insulation is placed. So it is what separates conditioned space from outside air or unconditioned space, such as a vented crawl space. And I'll show you more pictures as we get down further. It's not interior walls that are between 2 conditioned spaces. It's only the exterior building thermal envelope that defines the conditioned space. So if you have 2 stories, if you have a 2-story building that's conditioned, you wouldn't show that interior floor between those 2 conditioned spaces. You would only have 1 floor, the bottom floor. Maybe that's your basement, or you have a walkout basement, so it's your slab on grade. Another nice feature when you've defined that building thermal envelope is entering applicable building components or light components. So it's understanding what your construction is, where that building thermal envelope is, and then start defining that within the tool. So some helpful hints. Within the software, there is, as I call them, buttons for every assembly. There's ceiling, skylight, wall, window, door, basement, floor, crawl. That doesn't mean that you're going to choose from every one of those. You have to determine where your building envelope is defined first. You might not ever touch the crawl wall button because your crawl space is vented to the outside. The other nice thing is you don't have to list every component in the software. If I have 16-inch on center wood frame exterior walls, I can group all my walls together, all my exterior walls together, and show one wall if I want to. Height times length of that opaque wall area, and add them up, total square footage. I could group all my windows. If they all have the same U factor and the same solar heat gain coefficient, the SHGC, rough opening of all the windows, I could total them all up. I don't need to have, and I've seen these projects before, I've seen project data files that had literally 100 line items. You do not need to have 100 line items and enter every window. But if you do have designer windows, or you have windows that have different U factors, different label, you want to separate those out. And if you do, and let's say you get into starting separating out building assemblies, just be really careful that you might want to start separating out your walls. So, because it does a parent-child relationship, the software does. If you group them all together, that's great, put all your windows underneath. But if you start separating things out, then you want to separate your walls out and put the appropriate windows under the appropriate wall that you put into the software. And we'll take a look at that in the software when we get there. There's also another feature that is, quote, called Other Assembly. Each one of these, the ceiling, skylight, the buttons down in this screenshot, has a drop-down list of assembly types that you can choose from. Each one of them also has an option to choose Other. Other means that the assemblies that are within the software that already have a calculated U factor, that doesn't match your assembly type. Maybe you have a unique construction that you're doing in your building, and from the drop-down list, those don't match. So you have an option to choose Other, but when you do, you got to keep in mind that you are going to have to calculate out what that assembly is. So a complete calculation would be needed, total U factor. And then you would want to back up that calculation with your compliance report and your construction documents to the building official on how you calculated that U factor. So it's really important to take note of that one. Some other helpful hints, fenestration ratings. Where am I getting those? When you start your REScheck, you're going to want to know what the rated ratings are for all your fenestration. And when I say fenestration, that's your windows and doors, glass doors. Anymore, the codes have a default table. It's called the Energy Code Defaults. But those values don't even meet some of the prescriptive values in the code. So that option is available, and you can do trade-offs. And when I say defaults, it means that the code requires that there be a certain testing, certified, labeled, rated product through NFRC 100 and 200. Those are the 2 ones, U factor and solar heat gain. And I'm saying it really quickly, but if you have a question on it, we can get into it in a little bit more detail. But really what I'm saying is that you have to have an NFRC labeled product. And that's what you would enter into the software. The default values are really worst case scenarios. So that's a biggie that you're going to want to have as you get into these newer codes. Cavity R value, what does it mean? When you start entering your building components in the REScheck, if you're a new user, cavity R value is insulation placed between the structural members. Continuous R value is just that. it's rigid foam board. It could be structural sheathing, insulated siding, but it is insulation that has no thermal breaks and it's not between structural members. There's 2 columns in REScheck, one for cavity and one for continuous. So you want to make sure you know which one is applicable to your assembly type that you're entering for your building components. And after you've entered all your building thermal envelope components, there's a button called Check Compliance, and you'll want to click that, and then you'll want to look at your compliance results. The other thing that you want to look for is anything, and there's colors within the tool, and if you see anything in red, then that means that you have something that is missing or something is not right, and we'll go into some more detail here as far as what that is. So here's a screenshot of NFRC Labels product. This would be on the window, and it gives you the ratings that you need to enter into REScheck, which is the U factor, and depending on climate zone, the SHGC, which is the solar heat gain coefficient. The other values, the visible transmittance and air leakage and condensation and resistance, are not values or ratings that you would enter into REScheck, but they are typically ones that you would see on an NFRC rated product. And here is a screenshot of the differences of the teasers that we just talked about, cavity versus continuous insulation. So this would be between the structural members and foam board that's outside of the structural members. So this has interior rigid foam board on the inside of those interior walls there. Some other buttons within the tool, basement, floor, and crawl wall. So if you have a basement, and what defines a basement, which is below grade wall is really the term is, when you have walls that are more than 50% below grade and you're going to condition that space, then that's a basement. For floors, you got to determine where your floor is for your house. And when we're talking floors, it's the building thermal envelope. So if I have a 2-story house, and let's say I have a walkout basement, then I'm going to have a slab on grade. I'm going to have a slab on grade. Exposed edge of the slab is what I would have for my building envelope assembly for that walkout. You might, though, have a conditioned crawl where it's not vented to the outside, and then I'm entering my crawl space, my crawl walls into the software. And if I have a conditioned crawl space, then the floor above that crawl space would be an interior floor, and I would only be showing my crawl walls. So here's a nice screenshot of what's considered a basement, and this is actually of a walkout. So I have 2 sidewalls that are on grade, and as long as that grade is greater than 50%, then they're considered a below grade wall. And then the minimum starts at the basement walls, the prescriptive values are what starts the baseline for it from the U factor tables for the national codes within the IECC. The front wall is considered an exterior wall because it's less than 50% below grade. It's basically all above grade at this point because this is a walkout, picture of a screenshot of a walkout basement. So some other helpful hints. Entering your wall height. For basement floors, or wall height for a basement is you are taking from the top of the wall down to the basement floor. So typically for basement walls, they're 8 or 9 feet high. And your basement wall entry in REScheck, that it asks you for a couple more entries for that because it also needs to know depth, the depth below grade and depth of insulation. You can look at doing trade-offs, basement wall insulation, where you're not insulating the entire height of the wall. However, as you move in these codes up to, for example, the most recent code, 2015, it's really hard to trade off full height insulation on a basement wall in your higher climate zones, in your more heated demand climates, such as climate zone 7 and 8 and 6. So again, the basement wall inputs is more than one input: wall height, depth below grade, and depth of insulation. So the code has a requirement for depth of insulation, and it starts at requirements for full depth of a basement wall or up to 10 feet. And this is where, if you're not doing up to 10 feet or the entire length of that wall, height of that wall, you can do trade-offs. So let's say I'm not going to insulate that entire basement wall. I'm going to have to make up for that somewhere else. So as long as I have increased amount of insulation on another assembly that's better than code, I'm trading off that lower amount of insulation somewhere else. That's what a trade-off is. Some other helpful hints here is continuous insulation. So the software will assume you have exterior rigid foam board. When you enter a continuous R value into the software, it has to make an assumption. Cavity insulation is assuming that you have insulation in between structural members. I talked a little bit about colors, and here is a screenshot of colors. So red really means something is missing. And it shows you in red, if you look under the screenshot here, the gross area, I'm missing my square footage for my ceiling. So after you've entered all your building envelope components, or you've checked compliance and you see something in red, you're missing some data. The other thing that's going to show in red, and I hate to say this, is if your project is failing, it's going to show it in red. Green means good, and that would show a passing number down below. So green is, think of it as good, and that you have a passing project. Blue, if you see blue, you could be missing some information. And down at the very bottom of this is a screenshot showing a teaser that says no envelope assembly specified and TBD, to be determined. So if you see anywhere you have a TBD, then it's probably that you don't have some information entered and it's missing something before it can finish running a full calculation, the software. So here's a screenshot of REScheck and an actual report or an actual building envelope that's been entered, a data file. And there are some screen operations. So there's a compliance bar down at the very bottom. And this one is an example that shows in red. Red is bad, missing something or something's failing, as I said. And it shows it fails. You want it to show green when you enter your information. And then the status bar. And the status bar is nice because it can give you little helpful hints. So be aware of that, because as you're entering your information, look down there and see if it's giving you information that might be helpful to you as you start entering your building envelope components. I talked a little bit about trade-off and total UA. What is UA? UA is U factor times the area for each building assembly. So I'd have my ceiling, and I enter my ceiling. I enter the square footage, and you enter it into REScheck. It calculates a U factor, and that U factor already has an assumption for that ceiling component. The only thing else I would enter as a user is what am I insulating that assembly to? And once I enter the insulation R value, it recalculates that U factor, and it recalculates based on the square footage of that assembly, and that's your total UA for that assembly. When I enter my entire building, my building thermal envelope, at the bottom of the program, it'll have total UA of the entire building. And what it does, it's going to look at a code building, and it looks at the U factor, equivalent U factor table from the baseline from the code, and your climate zone, and it looks at the max UA and your UA. Those are the two biggie numbers. It's looking at if it were just meeting code, and it's calculating the overall U factor and UA, and then what you're proposing, your total UA. And we'll look more at this when we get into REScheck. There's also a performance alternative in REScheck. Now, I talked a little bit about whole building performance, and this is not a whole building performance tool, but it does have a simulated performance approach. And really what that is that it looks at your solar gains, and it can look at your mechanical equipment. It will do like for like on mechanical equipment, though. You're not getting trade-offs for mechanical equipment. But it will look at it, and it will look at the efficiency of the equipment and the solar gains on your building. So when I say solar gains, basically if you want to use this approach, you have to do all your walls. You're going to have at least 4 walls and show orientation. And orientation is a feature that you can choose that'll add another column to your spreadsheet, so to speak, and you will show every one of your walls and how they're facing. And when I say facing, is so you are standing in your house, facing the front door, and is it facing north, south, east, or west, whatever it might be. That's how you determine. And we'll play around with this a little bit in REScheck. But if you want to use the simulated performance approach, you would have to do all takeoffs for all your walls and show the orientation and put your applicable windows and doors under each wall. So some helpful hints if the compliance is failing. What do I do? Well, if you show a failing, first thing you want to look at is first confirm that you've entered all your building envelope components for the building thermal envelope. Check your square footages. Check that your insulation values have been entered appropriately. Check all your ratings on any of your fenestration that you've entered and the rough openings, so the square footage. And then start looking at where your big hitters are, meaning are you not meeting minimum insulation requirement for a certain assembly? Maybe you can't fit the amount of minimum insulation in a certain building envelope assembly, such as the walls, and you need to trade that off somewhere. So start looking at insulation values and then your fenestration. But keep in mind, the code is not driven by the amount of windows you have any longer. So stringency is not increased, or energy efficiency is, you're not penalized for having a lot of glass. It does like for like components. So if you have a lot of windows, as long as they have a really good U factor, the more square footage you have of that component and the better it is than the minimum code, you're going to get trade-off for that component. You'll be able to make it, you can use that for making up on a different component somewhere else. So it's really based on square footage. So don't think of it as that you can fail because you have a lot of glass in a house. That's not the case. It just means that you'd have to meet the minimum U factor and solar heat gain that's in the code for all that glass. If not, you're going to have to trade that off for another component somewhere else, and it's going to have to be better than code. So some other helpful hints, and I said UA. Here's a screenshot of what I was referring to in the column that will show you in REScheck. And I've circled 2, so I have a basement here that doesn't show an insulation value, and look at the UA. It shows 183. That's pretty darn high. And the reason being is I forgot to enter what I'm insulating that basement wall to. So that was a big hitter. So once I fixed that, then I was passing. What I also forgot is that I didn't show the depth of insulation. I showed the depth below grade, but I didn't show my depth of insulation either. So even if I entered insulation, my cavity and or continuous, if I can do continuous on my basement wall if I wanted to, I have 0 over to the very far right for my depth of insulation. So as you got to be very careful when you start getting into some of these building envelope components. If they're asking for more information, don't forget to enter it, because it's going to calculate it or it won't calculate it depending on what values or what, depth or height or square footage that you've entered there. So be very careful that you want to double check all your work once you're done. Similar to this slab on grade, the walkout basement, I didn't enter what my depth of insulation was. And for slab on grade, you're only entering that exterior edge of insulation. So from the top of the footing down, the distance that you're going to insulate that slab edge. And there are some diagrams in REScheck, the different ways you can insulate a slab edge that you can take a look at. And if you're doing vertical plus horizontal, then you'll add up the distance for both. So you could have up to 6 feet of slab edge insulation. You wouldn't have, if you had the entire slab insulated, that would typically only happen if you had a hydronic heating system within the slab. And when I say heated slab, I'm referring to a hydronic heated slab, meaning the actual slab is heated, not that the house is heated. That is a question that has come up, so keep that in mind. There are 2 options in the software. heated and non-heated slab. Requirements tab. There are a couple tabs within REScheck. So there's a project tab, an envelope, mechanical, and a requirements tab. Kind of new to the tool. It's only been out for a couple years. But this is where it has all those other requirements that are in the code, such as air leakage testing, mechanical systems, duct insulation, duct testing, duct service water heating, duct construction. You'll want to go through and look at all those provisions that are pulled in and confirm that you meet all those provisions and check them off, because that will actually get populated into the inspection checklist that you will want to turn in with your compliance report. And you're going to want to keep a copy of it, and you'll want to have a copy out on site that will be out there during inspection when the field inspector comes out. So you want to have one out on site as well. The other thing that you can do within the software is create a certificate, which is required by code. So here is the reports. So after I'm done entering my project and it passes, I would go up to the File menu, and I can click View Print Report, and I have options. I have Compliance Certificate, Inspection Checklist, and Panel Certificate. The panel certificate is something that you can create and that you'd want to take out on the construction site because it's required. And it will give you the average insulation levels and so forth that can be put out there and stays with the home after the home is built. So what else does the requirements tab have, and kind of how is it set up? The code requirements in the requirements tab are really set up based upon phases of construction for inspections, and those are written in the actual IECC, those phases of inspections as well. So there's a plan review section, there's a footing and foundation, and rough in, and then final. And that's kind of how we've set it up in the requirements tab as well. So you'll see those as you start moving through and you're confirming that you're meeting the other provisions. Here's a screenshot of an actual report. So this is a project that's been done, so you'll want to verify that you have the applicable code. This one shows 2015. That's the most recently published IECC. The location is correct. The construction type is correct. Is it single family? Is this an addition? Is this an alteration? What is the construction type? The conditioned floor area. This is the only time that you would enter total conditioned floor area. So if I have a 2-story house, I'm going to total up each floor. But under the envelope tab, you would enter just the building thermal envelope. You wouldn't be showing that interior floor, but total conditioned floor area is a biggie. So during plan review, when they're looking at the load calcs, that number comes into play because you need total conditioned floor area to run your load calcs. So that is an entry to enter into the software in the project tab. Climate zones automatically populated based upon the city that's chosen. And then you can put your permit date if you wanted to. You can put the date on your project in there. And then you have compliance passes. Of course, you're not going to turn in a failing report. If you wanted to create a report that was failing, you'd see that there wasn't a signature line because we will automatically remove the signature line if the project is failing. So if you don't see a signature line, go back and look and see if the project was failing, because that's probably why. And then the envelope assemblies would sit down below the compliance result. So it will list all the building envelope assemblies that you've entered into the REScheck program. It'll show the gross area of each assembly, the cavity and or continuous R values, the calculated U factor, and then the total UA for each assembly that you've entered. And here is just scrolling down another screenshot of the rest of this project. So this is actually a case study that I have that we'll walk through real quickly, and then we'll get into the software. So the signature line down below, it shows done right construction. Just kind of made that up. Anyway, that's where you can under preferences in REScheck, you can customize your signature line if you want to, and then you would sign it, date it, and submit it. Here's a screenshot of the inspection checklist. So with this one, this is an example of the 2009 code, but it'll give you the code section. You can ignore the next line item down, the FO1. That just means foundation number 1. It's actually a tracking feature for our data gathering. So that's really what that means. But 402.1.1 is actually from code. It's the code section. So that's another helpful hint. The slab edge insulation R value. Then the other columns are really for the plan reviewer and the field inspector. I have been asked that question as well as, am I supposed to fill those out? No. In REScheck, you'll go under the requirements tab and you'll confirm you're going to meet the measures. But once you create this inspection checklist report, the rest of this is done at the building department and out in the field. So the plans verified is for the plan reviewer to look at the building plans and confirm that everything is meeting code for permitting. Then the field verified is for the field inspector, and whoever that might be. Could be a third-party rater. Could be anyone that is tied to that building department that's going to go out and do the field inspection before they get certificate of occupancy. And the complies box is also for the inspector. Does it comply, not observable? Maybe they couldn't see it at the time of inspection, or not applicable. And then the comments column is in the requirements tab. If you enter additional information for a provision, it's going to show up there. If you look down towards the very bottom, you'll see that a protective covering is installed. It's kind of highlighted in blue, and it says requirement will be met. It's a checkbox in REScheck saying I'm going to meet this requirement, and I could add additional information if I wanted to, and it will show up on this inspection checklist report. Here is an example of one provision from the inspection checklist, and this has to do with the ACA Manual S and J for the load calcs. So this is where you would have to manually enter the load calculations for the heating and cooling. You don't enter this into REScheck. It's not a feature or an entry into REScheck. So here's the code section, or sections if it's in more than one section. The inspection type is the next column. The value for the plans, the value for the field, the compliance, which is typically done out in the field, and then we'll move over, and here's the screenshot example of the panel certificate. So this is showing you of the 2015 IECC, and this takes averages. So if I had 100 line items, which we don't want to have, but if we did, it wouldn't put 100 on this panel certificate. It's going to take the average amount of insulation for the above grade walls and enter the overall R value there. Same for below grade wall if there were any, and this one's showing 0. So this is an example of there were no below grade walls in this project. But it had a floor, shows the insulation, has a ceiling, showing the ceiling insulation, and so forth. And the fenestration, glass doors, that. But you'll see heating and cooling, you need to enter those efficiencies and the equipment manually and the name. So there is some other things that if you wanted to use this, you don't have to use this panel certificate. It's just a nice feature that we put within the software that you can create one because it's required by the most recent codes that you have one. But just keep in mind, there are some additional information that you need to manually enter if you use this certificate. Area Calc is a tool that we probably will not be supporting any longer, but you would see it in the desktop tool. It's not supported in the web tool, but it just runs takeoffs. It can save all your windows and doors, so if you're doing track homes and you use the same schedule of windows and doors every time, you could save them in Area Calc and just move them on into your project. That's what Area Calc is. Pretty basic tool. So let's take a look at the case study. And if you're online and you're a trainer, this might be a good case study that you can use to go back to your building department or what have you and use this case study for using for training. So this is a house that has a lot of different components involved in it. So it has a basement, it has a crawl, has a slab on grade. So the first thing you do is you're taking a look at the building section and the building plans, and you take a highlighter. And I can go on with a highlighter with my building plans and highlight that building thermal envelope. The other thing is if you was to take that highlighter and highlight around the building thermal envelope on your plans and you have to lift up that highlighter, then you have a break in your continuous air barrier. The code, the most recent codes require a continuous air barrier. You do not want to have a break in your air barrier. So another nice little helpful hint there. If you lift that highlighter up, then you might want to be taking a look on your building plans of why. If you can do continuous highlighting around that building envelope, good, because it's required by code that you have a continuous air barrier. So this shows the building section for the main floor and the basement section. And I'm giving you, for this case study, what the square footage is for the ceiling area. And this one has some knee walls, so it has a cathedral ceiling, and it has a typical ceiling. So there would be more than one ceiling entry, one ceiling assembly in the software, more likely. Here are all the exterior walls for this project. So I have some walls. I said I had some knee walls, so I have a cathedral ceiling. So I have some 12-foot walls on these plans. And I have some typical walls that are 9 feet. I've done the orientation and the square footage for this project. And the knee walls. When you have knee walls, and this really is for the plan reviewers, you might want to show those separately, and you can actually double click on the actual wall that is shown and change it to knee wall instead of it just saying wall. You know, that's really nice for the plan reviewer. It just makes it quicker that they can go take a look at a REScheck and go, oh, that's the knee walls, got it. And even out on site when they have the REScheck report, when they're going out there and they're inspecting the knee walls, and they might have a different insulation cavity R value than some exterior walls. And that's really important that you separate them out. So here's an example of some bad insulation done in some knee walls that are over to the right versus insulation installed properly in a knee wall. And really the side view of this house and where defining where the knee walls are, and that red line going across the ceiling area. So ceilings. Well, a lot of questions come in if you're a first-time user. How do I enter the insulation for a ceiling? Or am I entering it at the roof? The only time you would enter a roof deck is if you have insulation at the roof deck and that attic is conditioned. It's not vented to the outside. Typical construction has been attics that are vented to the outside and the ceiling, the insulation is placed down at the ceiling level. So that's where you're calculating your square footage, is at the ceiling. And if that's where it's at, it's typically the same. If it's a one-story house, then it's the same as your floor area, conditioned floor area, unless you have a garage and you're insulating above the garage. But again, if you have a thermal break there, you would not show that ceiling area as unconditioned garage. So with the insulation, if it's all one application, if I'm blowing in R38, I show that all as cavity insulation. I don't break out my insulation and show this much R value above the trusses and this is R value that's in between the framing members. REScheck already makes assumptions for the ceiling based upon the R value entered. If I enter R38, R49, it's running a series of calculations in the back end. It makes assumptions if you're using typical standard flat ceiling scissor truss that there is decreased amount of insulation towards the eaves. It's running that calculation as well. And only if it's an energy truss do you get full height, full credit for that entire R value for that ceiling insulation. So don't double up your R values for your ceiling. Enter it as cavity unless you're insulating truly with foam board at the roof deck outside of the structural members would you show continuous insulation for your ceiling or your roof entry. Basement walls. Again, more than 50% below grade be considered a basement wall. If not, it's an above grade wall. Different ways to insulate your basement wall. I can do it on the exterior. I can do it on the interior. I can fur out on the interior and have insulation between those furring members, and that would be considered cavity insulation in my basement wall. Or I might have a foam board on the exterior, and I'd enter it as continuous insulation in REScheck. Now if I have a 2-story, I don't want to forget about my rim joist. But where do I include that rim joist? Here's a screenshot that I wouldn't include that rim joist area. That would be part of my above my first main level. So if I had a typical 9-foot wall for my main level, and I need to include that rim joist area, I'm going to calculate 10 foot. If it's just a 1-foot rim joist, then I'm going to calculate out 10 foot high and then the length of that wall. I would not include it in my below grade basement and add the square footage there. I would add the square footage to my main level and show it as the above grade wall. The insulation is, by code, for your rim joist is supposed to be the same as the exterior above grade wall. So more than likely, you're going to have the same value anyway. You wouldn't want to separate it out and show your rim joist. And it wouldn't be considered the floor. That's part of the exterior wall. Here are the square footages for your basement wall. And in red is the actual slab on grade. So I have a side wall, the 2 side walls and square footage, and I have a back wall. So if I have a walkout basement, I'm definitely going to have at least 2 basement walls in REScheck, because I have one wall that's fully below grade, and if the 2 side walls have the same gradient, then I can total those up together. They're like components, and take the total square footage and show just one basement wall if they're both the same grade, and enter it up, and then do height of the basement wall, depth below grade, and then depth of the insulation, as long as I'm insulating both those side walls to the same depth. And if it's full height insulation, then you're good to go. Show it at full height. Here is a screenshot of the basement wall entries, because you're entering a little bit more into the software. So you have the wall height, the depth below grade, and then the depth of insulation. And you have the option that you don't have to insulate the entire height of the wall, but code minimum starts at full height. Just keep that in mind. Now to the floor. And for this case study, I have a crawl space, but the crawl space is vented to the outside. So if that's the case, the floor above the crawl is what I'm going to be entering, and that's where I'm going to insulate. I wouldn't be showing the crawl walls if I'm venting to the outside. I'm insulating that floor above the crawl. And this is the square footage of that crawl space floor area above the crawl. However, if this is an example of an insulated crawl space, then you would enter your crawl walls. So you wouldn't see any vents. You would be seeing insulation. You're going to see a vapor barrier laid down on the flooring of the crawl, and there's, mechanically ventilated. It's conditioned, and more applicable components would need to be submitted to the building department as far as how you are mechanically ventilating that crawl space. Similar to as if you had a conditioned attic, then more provisions might apply to you as well. Crawl space walls. One more entry for crawl space walls. It will ask you the depth of inside grade because of the soil. So one more entry for the crawl space walls if you have a conditioned crawl space. And then here is for the case study the slab. So 93 linear feet. This is the only entry in the software that's in feet. All the other entries are total square footage. So for slabs, there are different ways you can insulate that slab edge, and you'll want to make sure you enter the depth of the insulation and then the R value. So if it's 2 feet, 4 feet, make sure you do not forget to enter your depth of insulation. And then the R value of your insulation. R10, R5, whatever it might be. One point to make is, even if you're in a climate zone where the minimum requirements for in that climate zone does not require slab insulation, but you are working with a slab, just because the code doesn't require it doesn't mean you don't show it. You've got to have a full building envelope. So let's say I'm down in the panhandle of Texas and slab insulation isn't required. I still would show my slab for this house if I'm going to enter it and submit this to the billing department, you would have 0 for the depth of insulation on that project. Insulation levels, so this case study is giving them to you for the roofs, the walls, the floor, and the slab. Those are my building thermal envelope components. And I go out and I'm going to enter those into the software for whatever it might be, cavity and or continuous. And the window areas and door areas, rough opening, and I will want to have what the rated, labeled U factor and solar heat gain is of my products. So the U factor and solar heat gain is provided for this case study here. Now let's go take a look at REScheck. So I'm going to go ahead and open up REScheck. Maybe. Here we go. Okay. Give it a minute to make sure it refreshes onto your screen there. So this is the desktop version. We'll play around with this for about half hour or so, and then we're going to go right into questions. And so when I open up the software, let's take a look at the very top. So at the very top, it says Untitled because I haven't opened up a data file, and the data files are saved as a .rck. That's a data file. Since I don't have one open, it says Untitled at the very top. Hopefully you can see that. It's kind of small. This gives you the build version. It says 462, and then the code that's already it's defaulted to, as so to speak. Once I've chosen a code and I close REScheck and I open it back up again, it's going to open it with that same code that I was on the last time I was in it. So the last time I was in REScheck, I was on the 2015, so that's what it's on. The next down below that is the menu bar. So I have File, Edit, View, Options, Code, Tools, and Help. Under File is I can save, I can open up a data file if I have an existing one, and we're going to look at one today. I can save it as a data file. I can save it as a report. 2 different data types. If I save it as a report, it saves it as a PDF. So if I hit Save or Save As here, it's saving the data file. And then I can do View Print Report. And the screenshots that I showed you was of the actual case study that I had showed you earlier today. We'll take a look at a report. And the email report feature. So let's click on that one. So here's where, if I have my project, I can go in and then I can specify what do I want to email over to the billing department. And it'll default to click all those files on, so the compliance certificate, inspection checklist. I can unclick panel certificate if I don't want that to be emailed over to the billing department. So you can unclick those. You can create an RTF. Maybe I want to upload that into a CAD drawing. That's a nice RTF feature if you wanted to do that. And then, will these projects be submitted for approval? You got to click yes or no here. So if your project's done, then you click yes and then hit OK. And then you can, once you do that, the next screen will be, who am I sending the report to? So you kind of just follow it through, and you can then send off that compliance report to the building department if you have their email address and the building department allows you to electronically submit. So we want to make sure that you confirm that with them, that you can do electronic submittal. Up at the top, again, we have the edit. There's an edit button, and you'll see that those are grayed out. If I click into one of the screens, and then some of those features become live. So under edit is the preferences that I talked about. This is where I can customize some things in REScheck. In the General tab, there's a General, Project, Applicant, and Reports tab that's under Preferences. In General, that's where I can save to a file location if I want to. I can block other users from opening a currently open data file. You could click that. I leave mine unclicked. I can look at version updates every month, never every 6 months. And then the upload usage data. If I unclick this, this only is applicable that when I install a new version, we can actually capture the data at that time that you're installing a new version. We don't capture it every time you save data. It'd only be if you're installing a new version where we could capture it from a desktop data. But the web tool, again, if you are using REScheck Web, you can save your projects to our server. Again, we don't share any proprietary information with anyone. So that's that feature. Project tab. This is where I can default the code, the location if I want to. So if I click on use the following settings, and if you change anything under preferences, just make sure you realize that you have to go back out under preferences and fix it, because it will save it. And every time you open up REScheck, it's going to be there. So you'd have to go back out and change it under preferences when you start customizing things with under this feature. So I can enable orientation I want to show up every time, or enable comments to show up every time. I'm not going to click on those. I'll show you that under the envelope tab. Here I have customized my reports that I don't want to have to deal with every time I create a report. So I've entered the owner and the designer. And then I've also entered the construction person, which is just a made-up name, but I've entered that in as well, that I want for that to show up on the reports. And then I can click OK. Up at the top again, glazing requirements under the View menu is when I start entering my building envelope, it's going to start calculating area weighted averages. A nice feature is because it's going out and looking at code, and it's looking what you've proposed, and it will start calculating up what's the maximum allowed if there's hard limits. And there are, when I say hard limits, in certain climate zones you can't go over a applicable U factor or solar heat gain coefficient, no matter what you do. Trade-offs stop. So you might want to take a look at, if you are in a zone where there is a hard, you start entering your building envelope components, this nice feature here will calculate up your area weighted averages for you and show them to you. Under options, this is where you have the UA or the performance alternative. So my suggestion is don't choose the performance alternative. Use the UA because, again, you have to enter a lot more assemblies by going down the simulated performance approach. I'd only go there if I was failing and I wanted to look at, I had really good orientation and some really good windows based on my orientation, and I wanted to get credit for that. That's basically what you're going to see is what it's calculating. It's not full performance-based tool. The other thing is you can define that you want to show orientation. So if I click on this, it's going to add another column down below. And then comments. Let's say I want to add some comments to my assemblies. So I clicked on that, and you'll see that it added another column. So now I have a comments description. It's optional. Maybe I have some certain features or things, or I want to show where on the building plans that a specific wall might be for the plan reviewer to look at, or the inspector. Then the other thing that's back up to the top again, where you are now looking at code, and here are the applicable national codes, and then here's some state-specific codes that are in there. We're on the 2015, we'll just leave it there. Then the area calc takeoff tool, we're no longer supporting this tool, so it's just a real simple tool that you can actually just run your square footages in and save windows and doors. Pretty easy to use. And then the help. And in the help is where the entire software user guide is. Could take you out, look for updates, frequently asked questions, and help topics like how do I enter my above grade wall. You can find a lot of good information under help topics. If you are thing, I would go to help topics first and look at that information out there and see if something out there can help you. All right, so the next item down is these are Windows type features, the cut, paste, save. Those options, duplicate, I can duplicate rows, I can print from right here if I want to do. And then the next item down are the tabs within the tool. So I have project, envelope, mechanical, and requirements. So if I click on the project tab, this is where I choose my location and my city from the drop-down list. I've already chose my code from the code menu, so it's defaulting to the 2015 here up at the top. And now my project type. This is where new construction, addition, or alteration would come in. My building characteristics. Is it a 1-2 family or a multi-family? And then that condition floor area. The condition floor area is all floors that are heated and cooled. So it's a 2-story, 3-story, total of all the floors that are conditioned. Only time you enter it here. The rest of the time, it's the exterior building thermal envelope of the assemblies in the envelope tab. For this code, there are some other things that apply that it wants to know, such as, are the ducts and air handlers within the conditioned space? Do you have a sunroom? Do you have a spa or a fireplace? Because there are some items that are code-driven that will actually automatically display. If you do, it's going to add those in. So pay attention to those. Click on them if they're applicable to your project. Over to the right-hand side is the project details. And so I would go up and I would click on the Edit button, Edit Project Details, and I could start entering my title, my owner, agent, designer, and so forth under the right-hand side of the screen. Let's take a look at the Envelope tab. I have nothing in this project. So here are the buttons, the ceiling, skylight, walls. This is where I start building my building envelope. So if I click on ceiling, it has a drop-down list already there for me to choose from. And I would choose one that is applicable to my construction type. If one of these matches your construction type, choose it because it's going to calculate. It's already going to have a calculated U factor for that assembly. So if I have a flat ceiling, I would click on it and you'll see it calculates what that U factor is. It's going to recalculate that U factor once you enter some more information. I'd enter the total square footage of that ceiling area. So let's say that it's 2,000 square feet. And then what I'm insulating it to. And let's say that I'm installing R38 in the ceiling. It recalculated what the overall U factor was for that ceiling area. And then it also calculated what the UA is. And if I wanted to add some notes, I could put some notes in here that this is, if I wanted to put, it already says flat ceiling, but, if I wanted to put some special notes in here, I could do so. If I have a skylight, I would choose skylights. If I don't, then I skip over to the next button. So now I'm going to enter my exterior walls. If they're all the same construction, and I have, let's say, a 1-story house, I could just create one line item if I wanted to. Height times length, total square footage, enter it. Cavity and or continuous. If I'm doing insulated sheathing, I'd enter it. But if I'm not doing insulated sheathing or additional rigid foam, I'm just insulating between the structural members, then I'm going to enter my cavity insulation of what the overall R value is under cavity and be done. And it recalculates the overall U factor. So it already takes into account what the air films are, gypboard, framing percentage. These are things that are already calculated within the tool based on ASHRAE fundamentals. Then I would go down to my windows and define the window types that I have. So if I have wood frame, vinyl, double pane, low E, and the rough opening. So if all the windows have the same U factor, I can look at my entire window schedule and put all the windows in. So I've totaled them all up. And if all the U factor is the same, I can enter my U factor. And then if the solar heat gain is applicable, I can enter my solar heat gain. So I'm going to put 0.40 and anything special that I might want to add to this. And total, there's all my windows that I've put in for my project. Same applicable as doors. Typically, you'll see doors where you might have different ratings, especially if you have like a glass door in the front, maybe a solid door, back door. You want to go pull the applicable U factors for your doors and enter each one if they're different. And again, put the value in. Then we get into basements. If I have a basement, this case study has a basement. So again, it has a drop-down list of assembly types you can choose from. Let's say that this one's solid concrete. I have the wall height, so I could put in a 9-foot wall if it was 9 feet high. the depth below grade. So let's say it's 7 foot below grade, and then my depth of insulation. And if it's more than 50%, that's when it becomes a basement wall. So if you had, if it was less than 2 feet, well, this is depth of insulation, excuse me. Here's where you're looking at, if you don't start at full height of insulation, then you're having to make it up somewhere else. And it'll populate it up into these columns up above. So let's put that we're going to insulate the entire height of this wall. So up here, I talked about colors. This is where it's showing something in red. And down below it says invalid areas. It's kind of like a little teaser for you that I'm missing the square footage for my basement. So as you're starting to start entering your project, take a look at the colors, take a look at what could be missing, and pay attention to things that might show up and items down below as little informational tips. For this one, of course, it was quite easy. I hadn't entered the square footage for my basement walls yet. And then what I'm insulating my basement walls to. So if I'm furring them out and I'm putting in insulation in between the structural members, it would be cavity insulation, and I'd enter it as cavity instead of continuous. So now we get over to floor, and this is where I have a floor above a vented crawl. Then I would enter a floor over unconditioned space, or do I have a cantilever floor over outside air? Do I have a slab on grade, and here's heated and unheated? So really, before you start your project, as I mentioned, that you want to make sure you know where that building envelope is, and then start running your takeoffs from there as you start entering the stuff into REScheck. So with this one, there were 2 floors. We had a floor over a vented crawl space for the case study, and I had a walkout basement. So I had a floor over unconditioned space, and it gives you a little thing that actually tells you some little warnings. Don't double up your insulation values is another warning that might appear, and you can click on don't show me this message again if you don't want to see it again as well. So with this one, I would enter up the floor area, enter my insulation, and again, with this one, I also had a slab, so I click on the floor button again, and I'm going to show the slab on grade. Heated means I have hydronic in the actual slab, and I'm showing this as an unheated. So I click unheated, and the diagram. This is where I take and I would total up the whole depth of the slab edge insulation. So if it's horizontal or horizontal plus vertical, then you would tally that up, and you would enter the depth in the box here. So let's say I have 4 feet. And I click OK. Then I would enter linear feet of that slab edge, not square footage. And then the R value of that insulation. And another little pop-up warning comes up for you to say, make sure you enter that in linear feet. So the continuous insulation would also get entered, and I already entered the depth of insulation. For crawl spaces, but the crawl on this case study was vented to the outside, so I wouldn't be showing it, would be one more entry that I was showing you on the actual screenshot earlier, that I have wall height, depth below grade, and then the depth of insulation, then depth of inside grade for calculating that crawl wall, the U factor for that crawl wall. So a little bit more involved in the crawl wall if you have a conditioned crawl space. Now let's go take a look at mechanical. For this one, there are no trade-offs, and I talked about that. So you're not entering a system unless you go the simulated performance alternative. Then it'll allow you to enter a mechanical system. Let's go over to the requirements tab. This is where I talked about all the other provisions that are in the code that you'll want to go confirm. But before we start clicking through these, I want to open up the actual data file for this case study. So I go to File, Open Recent. I'm not going to save any changes to the information that I just entered there. I'm going to hit No. So now I have an actual data file in there, and now it's populated. So another thing I can, if I can't see my components, I can grab a hold. It's almost like an Excel spreadsheet. I could grab a hold of that column and move it if I wanted to. Over here between the assembly and gross area, I can scroll that out more so I can see the rest of the assembly type. When I talked about knee walls, I can double click with my mouse and change that. It'll keep adding up, wall 1, wall 2, wall 4, but I wanted to show the knee walls in my compliance report, so I could double click there and type knee wall in, which I've done. The other thing that you could do is maybe there's an entry that I want to delete. I could highlight it. I can come up and I can go edit and delete that row, or I could duplicate that row if I wanted to. So those are some functionality things. We're not going to mess around with that because I want to keep this case study the way it is. Over on mechanical, I would have to change my compliance option over to not UA, which is showing down at the bottom. Compliance method is UA trade-off. And my UA versus max UA, and this one's showing I'm 14.6 better than code. So why would I want to go down the simulated performance route if I'm already passing by UA? I wouldn't. I'm good. I'm meeting code. I'm good to go. But you do want to click on the requirements tab. And these red X's means I haven't confirmed the provision yet. And once I confirm it, it'll show up. All right, said red's bad, green's good. So let's start going through these. And I'm not going to go through every one of them. You can do it, and it's all code dependent as well. And envelope and system, there's different requirements that will be under each one of these radio buttons. So the first one that comes up is the air barrier. I talked about a continuous air barrier. Will this requirement be met? And it gives you the code section. And I click, yes, it will, and it shows up in green. Then I can also put, if I want, where is it specified on the plans. If you don't want to put where the location and plan specified, you don't have to. It's optional. Then I just keep going down the list. I also talked about fenestration has to be tested, or if this is site-built, listed, and labeled. Am I going to meet this applicable requirement if I have site-built windows? If I don't have site-built windows, then this wouldn't apply. And I would click site-built windows if that's applicable. Now, the next one, do I have any recessed cans? If I don't have any, I would put requirement is not applicable. If I have some, they have a provision that they have to be airtight and less than 2.0 CFM for air leakage. I'm not going to go into these code provisions because this isn't a code training class, but this is where all you would really want to go through and make sure you're reviewing all of these other code provisions that are in the code that you've chosen. And you just go down the line and keep going through, and as each one you go to, it's going to change it from red to green as you have confirmed whether you meet it or it's not applicable. Once I've done that, then I can create my report. So I would come up to File, and I would go View Print Report, and then you have the option and say, yeah, my report's complete. So I'd click Yes. I click OK, and it's going to create the compliance report. So I'm going to give it a minute here. And here's almost looks like the screenshot that I showed you earlier. Here is the report that has been entered for the case study. That's part of this slide that I showed you. And this case study will be available out on energycodes.gov. So if you are a trainer, it's a nice one to show. It has all the different features in it. And what am I taking a look at here? I want to make sure that it's passing the max UA and your UA. Here's the area-weighted averages. So I have the area-weighted solar heat gain and then my proposed solar heat gain. Then I go down the line. So if I'm a plan reviewer, I'm basically going to start looking at each one of these assemblies, the square footage, and what the proposed insulation value is, and compare it to the plans. If you have an assembly in here that does not have an insulation value and it only has a U factor, then the user has chosen other in the software. That's where I mentioned that if one of those assembly types doesn't match your construction type, every one of them you have an option to choose other. However, you have to enter your calculated U factor and you need to back it up with paperwork on how you calculated that U factor. So keep that one in mind as well. If you see dots through the cavity and continuous R value columns, then they've chosen another and they've calculated that U factor, and that's not a problem. That's an option for you to do so. You can do that. Just make sure that you've double checked and that you have your backup documentation on how you arrived at that U factor is all. Anyway, as I scroll down a little further, you'll see that there's a signature line and it has this entire case study in here. I keep scrolling down. It has the inspection checklist, and I would want to keep a copy. These are all the provisions that were in the requirements tab. And any notes, if I had any notes, would show up under the comments and assumptions as well. And that is about the basics of REScheck. So we've gone through, we've taken a look at the software. We looked at how you enter building envelope assemblies. We've looked at a report, how you create a report, how you can email a report. And now I'm going to go back over to the PowerPoint, and we are going to finish up with some Q&As. Okay, so let's take a look at the questions that have came in. One question that came in is, can you access the software from a smartphone? It's not set up to operate on a smartphone. We are looking at changing the tools within the next couple years. Will probably be all web-based software, and the function will look a little bit different, but we do not have that feature. You know, it's not equipped to have a feature that would work with a smartphone right now. You could try it, but it's not set up that way. Another question is, if an owner adds, for example, a bedroom, is compliance with REScheck required? Yes. So if I'm adding conditioned space to an already existing house, such as a bedroom, a family room, that's considered an addition. And you know, whether you use REScheck or another method, if within your location you have to show compliance to the energy code, you're going to be submitting something for documentation. So if REScheck can be used, I would use REScheck, because it's an easy way to create a compliance report that you could submit to the building department. Another question that came in is, will you have a webinar on ComCheck? Yes, we will. We're going to have a webinar on how to use the commercial software application called ComCheck. That will be later on, so go back out to the energycodes.gov website and periodically look at the resources under training, and we will list the topics of webinars out there, and you can register. We have the next one that's coming up next month will be on lighting, commercial lighting requirements. Another question came in your example. You did not mention the windows that are facing at an angle, like southwest, northeast, etc. How do you enter those? That's a really good question, because in REScheck you can customize the orientation. And so if you have orientation on, you can actually specify degrees north and face your building at an angle if you wanted to. Keep in mind this little nice feature that's in the desktop tool, where you can put your building at an angle, a north-facing angle from north degrees. The tool's still not a performance-based tool, but if you're doing the simulated performance approach, it's going to look at that angle and your orientation, and you might get some credit for good orientation and how your windows are facing. If not, again, you don't even need to show orientation. Another one, is it possible or necessary to sign an emailed report? As I mentioned earlier, as long as the building department allows you to electronically submit your compliance report, that's what you want to confirm, that you can submit electronically a compliance report. Maybe they have your stamp on file, or you're a professional designer that's registered with the building department and they know you. Then they're like, yeah, we know so-and-so, he could submit those electronically. You want to confirm that with them before you start submitting anything to the building department, definitely do that. Another question that came in, would you enter the square footage of an entire house or just the square footage of the addition in the conditioned floor area? So I think what this is asking is, on the project tab of REScheck, the only time you'd enter every floor, if you have more than one floor that's conditioned, meaning it's heated and cooled, is under the project tab, and it's asking for conditioned floor area. If you just have an addition, you would only enter, and you're just doing the takeoffs for the addition, then it's just the square footage of the addition, not the part of the house, the existing part of the house, just the addition only. So that's, let's say it's a big bedroom, you know, a couple hundred square feet in the bedroom with an ensuite bath or whatever it might be. Only that floor area is what you would enter in the project tab. Another question came in, when you enter a wall area, do you subtract out the fenestration? Another very good question. No, you do not. The software automatically does. When you choose wall, you're doing the opaque area, so it's the height times the length of that wall, no matter how many windows or doors are in that, because once you enter the windows or doors underneath that wall, it subtracts out the window and doors automatically. So let's say when I said like for like components, if you're going to tally up all your exterior walls in one line item, then you got to enter all those windows and doors under that one line item. You could have additional, you know, more than one window and door under that one wall if you wanted, but when you start breaking out your walls, then you really need to have the appropriate windows and doors under each appropriate wall, because it does subtract out that area. If you don't, you might see something come up in red, because if you have more window area than wall, it can't, well, it's going to ding at you, because you can't do that, because it's trying to subtract from a wall area that where's the wall. So keep that in mind. When it comes, here's another question that came in. When it comes to slab on grade insulation, it is only applicable by zones. If I'm in climate zone 3A, I will require slab insulation only if it is a heated slab. Is that correct? Well, it depends on what code, for one. And then if it's heated, in the most recent code, if you have a heated slab, there is a footnote, but that's for the insulation and fenestration table. REScheck uses the equivalent U-factor table, and that's different, but it does require that heated slabs have in the insulation table, this is now code-driven, insulation underneath the entire slab, because you're going to have heat loss if you have hydronic heating, and that's what the intent is to prevent that heat loss, because you have that hydronic system in the slab. If you are in a climate zone that requires insulation. So probably didn't answer that one completely for this person. If not, they could submit the question in through the help desk, and we can get more specific for them. Another question that came in, have you had an addition where there was only 3 walls, and how do you resolve that? That's fine. You're not penalized. If you choose addition, the software is already assuming that you don't have 4 walls. And you typically would only have 2 to 3 walls for an addition onto an existing house. Or, you know, you might be dealing with 1 wall entry because you're doing it all under 1 wall because it's the same construction type. And that's fine. You're not going to get penalized for doing so. Does your case, this is another question that came in, does your case example show the calculated U-factor values when the R value was left out? All right, so if you choose one of the assemblies in the software from the drop-down list, it's going to calculate a U-factor automatically, because it makes some assumptions based upon the assembly chosen, whether it's steel frame, whether it's wood frame, and it's all based upon the typical components that would be involved in that assembly that you've chosen in the software. And if you don't enter an R value for insulation, then it just stays at the U factor without any insulation for that assembly. And if you enter an R value, it recalculates. So it's doing the reciprocal. R value is reciprocal of a U factor. It takes that R value, recalculates it as a U factor, recalculates that entire assembly as an overall U factor, and then UA. Another question that came in, should a knee wall have sheathing on an unconditioned side of the wall? This will depend on the construction. So again, this is going a little bit more into code than it is the basics of REScheck, but the software will assume you have chipboard if you choose and you have a knee wall. If you have insulated sheathing, you need to enter that as a continuous R value because it automatically will remove the chipboard component from the calculation and put in the insulated the continuous R value that you've entered as insulated sheathing. If that is the case, for this one, it will depend on the unconditioned side of the wall. So, you know, if you have sheathing because your other side is a conditioned space, it can depend. And you know, I'm not going to go any further on that one. The requirements do not appear. I don't know what that.
It's a question. Do the requirements not appear in the printed report?
Well, the report is separate from the inspection checklist. So you'll want to tie the two together really because all the other applicable code provisions are in the inspection checklist. I recommend you always click on both those buttons. That's why they're defaulted to be clicked on when you get to where it says File, View, Print Report. You'll see that the three little buttons and the panel certificate is defaulted to be clicked on. You don't want to forget the inspection checklist. I mean, it should go hand in hand, to tell you the truth. I think we have time for one more question. Actually, we only have one more question, so we will get done. Oh, two more, and we'll get done a little early. Would it matter for a basement walkout whether you use a regular wall or a basement without? Below grade.
With 0 feet below grade.
I'm reading it and I'm at the same time. So would it matter for a basement walkout whether you would use the regular wall or basement? It does matter because if you have a walkout, that front portion of the walkout is considered an above grade wall. The code is it's a basement wall if that overall wall is more than 50% below. Then it looks at below grade walls as the baseline. If it's not, if you don't have more than 50% below grade, it's going to look at above grade walls as the minimum baseline, and those insulation values are different in the prescriptive table. And that's where the baseline starts, is that U factor table, that prescriptive table. Not the insulation table, but the U factor table. And there is a below grade wall, basement wall column in those prescriptive tables. So you need to be really careful about that. And so for a walkout, you're going to have one wall that will be above, totally above grade. And you just choose it as an above grade wall. And the next question came in, how does exterior rigid insulation affect the moisture on a basement wall? Isn't insulation supposed to be installed on the warm and winter side? Depends on what climate zone. I definitely refer you over to the IRC basements, and insulation and moisture can be a big deal depending on the location that you're in and how you insulate. And do you have an air film with in between the like concrete masonry? Do you have an air film to let that wall breathe? And where are you insulating that wall? Do you have water management for that wall? A lot of that comes from the IRC. I would go to the IRC for more provisions on water management and the insulation placement and the climate zone that you're in. The ICC addresses some of this, but the IRC really goes into a lot more detail. And I believe that is one of the last questions that we had. And thank you, Jen. I'm going to turn it back over to Jennifer.
So thanks, Pam, for sharing all your knowledge on REScheck with us. Just one final announcement before we sign off for the day. If you had any ideas or suggestions for more webinars, since we haven't quite filled our calendar yet, please again send those in to the email that's included in your webinar reminder emails. And thank you for participating in today's webinar, brought to you by the U.S. Department of Energy's Building Energy Codes program, and we hope to see you next month.